Hello, this is Mrs. Taylor, and I'm going to review the 3 homework problems so that you have an idea of what we did with solving systems by substitution in class. So, number 1A, the system was y equals x plus 3, and then y equals 2x plus 5. And what we learned in class was that this y is the same as this y. So if that's true, if this y equals x plus 3, then this y equals x plus 3. Therefore, I can take this y out and substitute x plus 3 in its place. So what that would look like is this y would become x plus 3, and that would equal 2x plus 5. Now that I've done that, I have one variable, and if I solve for that, I get that variable equals a number, which is our goal when we solve systems of equations. We want an x value and a y value. So using our solving equations skills, I want to move my x terms on a side together. So I'm going to subtract that 2x from both sides. This x is understood to have a 1 in front of it, and 1 minus 2 is negative 1. So that would be negative 1x. Bring down the plus 3 and this positive 5. Now I need to move my constant terms together. So I'm going to take this plus 3 and subtract it. Those would cancel because 3 and negative 3 make 0. 5 and negative 3 make positive 2. And then my last step to solve is to divide both sides by negative 1. So x would equal negative 2. That's just half my answer because the system in 2 equations has an x value and a y value as its solution. So I take this x value, this x is the same as this x and this x. So if this x equals negative 2, these x's equal negative 2. So I can take this value and plug it into either equation and solve for my y. I'm going to choose the top one. It's your choice. So that would be negative 2 plus 3 because x plus 3 becomes negative 2 plus 3. Negative 2 plus 3, well, that's 1. So y equals 1. So my solution is negative 2, 1. And I can check my work, take this x value, plug it in, this y value, plug it in. And if it's correct, I should get a true statement. That one checks out. Hope you can't see that, sorry.
Favorite teacher.
So then, after I check that one, I could check this one.
It's in the video.
2 and negative 2 would make negative 4. And negative 4 plus 5 is 1. So that one checks out as well. And so I know my solution is the correct solution to this system. And that would be 1A. So 1B is a little bit different. 1A, you had y solved for both equations, and 1B, only the top equation has a variable by itself. But that's okay because I can still take what x equals for this equation and substitute it for the x in this equation because this x is the same thing as that x. They're equivalent. So what that would look like is I would rewrite this equation, but I would substitute 2y minus 4 for x. So instead of x, I would write what x equals, which is 2y minus 4, and then continue writing out my equation. Now from there, I have only one variable, so I can solve. These are parentheses, but there's no number directly in front of it, so I don't have anything to distribute. I could distribute a 1 if you want to think of it that way, but basically what happens is those parentheses disappear. Now I solve the equation. First, combine my like terms. 2y and 8y make 10y. And then I would add 4 to both sides. And that would give me 10y equals 20, and then divide by 10. Hello. So y equals 2. That is half my solution. I still need an x value. So I take that y value and I substitute it into either equation, and I can choose which one I would like to substitute. I'm going to substitute it in the top one. Once I substitute y is 2 into this top equation, I get 2 times 2 minus 4. Well, order of operations, multiply first. 2 times 2 is 4. And then 4 minus 4 is 0. So it looks like my solution is 0, 2. And of course I need to check it. So I'm going to use 0, substitute it for x, 2, substitute it for y. So that'd be 0 equals 2 times 2 minus 4. And once I simplify that down, oh, it does check out. 0 does equal 0. So now I test it in the second equation. 8 times 2 is 16. 16 plus 0 is 16. So that one checks out as well. So I know that my solution is correct. All right, 1C from your video. This one is the most complicated situation where you don't have a variable solve for. And so you have to make a choice. And it doesn't matter which variable you choose. You can choose this x, this y, this x, this y. Doesn't matter. A lot of people like to make the easiest choice. So you may see here that all you have to do is subtract 2x from both sides. Or here, it's really simple to solve for one of those variables. It's totally up to you what you choose to do. So what I'm going to do is I'm going to take this bottom one and I'm going to solve for y. Because if I solve for x, if I plug it in here, I would have to multiply it by 2. And I think I would rather just avoid that if I can. So I'm going to solve the bottom one for y by subtracting x from both sides. And now I have a variable to solve for. So this y is equivalent to this y, which means I can substitute. So 2x plus y equals negative 4 becomes 2x plus negative 7 minus x equals negative 4, because that's what y equals. So from there, again, there's nothing to distribute. There's nothing in front of the parentheses. So I can basically drop them. Plus negative 7 becomes minus 7. I combine my like terms, so 2x minus x. That would be an understood 1. So 2 and negative 1 makes 1. So that would be 1x, which is just x. Continue to solve by adding 7, and x equals 3. So that's half my solution. I need to substitute it into either equation to solve for y. I'm just going to plug it in the top one. So 2 times x would become 2 times 3, which is 6. Subtract the 6, and that would equal negative 10. So it looks like my solution is 3, negative 10. But I still need to check it. So 2x plus y would become 2 times 3 plus negative 10. 2 times 3 is 6. And 6 and negative 10 do make negative 4. So that one checks out. But it also has to be a solution for the other. So x plus y becomes 3 plus negative 10. 3 and negative 10 do make negative 7. So it checks out for that one as well. So now I know that my solution is correct, and I'm done.